Hello to everyone once again, and thank you for attending this webinar. I'm pleased to welcome you for this today's show or today's webinar, talking about the deep end mill or deep machining, allowing you to make some prints with a high reach. If you have small diameters or small radius to make internal with a deep reach, then you are at the right place. And for this, I will present our series, end mill series 1430 and 1450. As always, you will have the ability to ask me some questions that will be answered at the end of the webinar, but you can post them anytime on the Q&R square in the back of in the bottom of your screen. In parallel, I will also ask you some questions, some questionnaires, and there will be 3 of them. I will leave you 20-30 seconds to answer. And we will start with the first one in order to know, because it's important for us that you answer this kind of questionnaire, because it drives us to develop the right tool for you. So, what kind of problems do you encounter with deep machining? So I leave you some seconds to answer. It's always interesting to know for our customer what pushes us to develop a certain type of cutters. So this time, for this series, we were pushed by the medical industry to develop a cutter which was doing a perfect surface state without any vibration nor burrs to machine internal prints. At first, the medtech has said industry pushes us to do that, mainly for doing the torques or the hexalobular prints. So far, not too difficult, you would tell me, but as mentioned at the beginning, they wanted to have one cutter, the same one for roughing and finishing, without any vibration, with a perfect surface state, without any burr, and machining stainless, cobalt chrome, or titanium. So the 3 main material used for doing medical screws. So our R&D team worked hard in order to develop that cutter that you see on the screen. So the small animation. This is a 1450 end mill series, which allows you to have a high reach. And so you have two types of cutters, the 30 series and the 50 series. And you will tell me, okay, what is the difference between each other? So they are mainly the same or similar cutters, but here you do see the technical description. The 1430 has a 3 times D reach, and the 1450 has a 5 times D reach. If we go a bit more in detail, we see that cutters have the same geometry. However, clearance is different. They have 3 teeth from 0.2 to 0.3 millimeter diameters, and starting at 0.35, it has 4 teeth. The maximum diameter is 1, standard and in stock, and have a helix angle of 45 degrees and a cutting angle of 14 degrees. The big advantage of such a cutter, you can see also in the small icon second on the left-hand side, it does have a big core, which make the cutter really rigid, allowing the chips to be evacuated. Talking about more in detail about the geometry, you can see here on the bottom side what you can find basically on the market generally, and this was also our first generation. our aim was to develop a cutter which had no vibration, as said, and in order to damp this vibration, our R&D team developed special geometry. So after the cutting lens, you can see there are three radius with different dimension, of course, which connect to each other without any rapid modification in terms of diameter. So this damps really the vibration and makes the cutter really rigid. Furthermore, you also see the section of the cutter. So on the upper side, the green and red section, you can see the cut AA and BB, AA in red and BB in green, which has 0.16 and 0.18 square millimeter. If you compare that to the lower image, on the DD cut, you see that it has, I would say, only 0.15 square millimeter. You might say, okay, it's not that much of a difference, but though at the end it makes the cutter a lot more rigid. So all this makes this cutter once again rigid, handling the vibration really much, which helps in terms of surface state at the end of the effect, the better surface state and the burr limitation. But if you want to see this cutter in force, I propose you to see a video, and you will see it after seeing me giving you some more information about the cutting parameters the machine had. So what you will see, so the machining was done on a micro 5 machine. So it's a really rigid machine, but really dynamic. So the spindle can go up to 60,000 RPM, and you see that we mostly or almost reach that value with our cutter. So you see the for operation, there will be the whole drilling, or actually it's a milling operation. So we will use the 1520 with a diameter of 2, a cutter with trio coated, turning at 48,000 RPM. Then the same cutter, which is different, but the same type of cutter, the 1450 with a diameter of 0.5, so it's pretty tiny, 0.5 millimeter for the roughing and finishing, starting at 50,000 RPM, and for the finishing at 50K RPM. And then to finish, chamfer cutter 102-2 diameter 4, and also Nemo coated, which will make the 120 degrees angle chamfer. So let's start the movie. We'll see here. So the cutter used, so it's a 1450, and here you see first the drill or the hole making. So it's interpolated interpolation of a hole done with an end mill. Then we do the roughing step by step. The cutting length is the step. And once this is done, we use the same cutter or the same similar cutter to do the finishing. This finishing is done on an interpolation way, so that you can have minimal connection or connecting lines, so as to have the best surface state. And to finish, the 120 degrees chamfer tool. So I left 506 chamfering, so as to have the time to see the cutter in force. All right, so the standard machines are not that dynamic as the Micro 5 machine. So we see here, or we show here the different or the standard cutting parameters that you can find. So the machining was done on a 316L stainless. So it was a machine that, as you have seen, between 50 and 55K RPM. And standard machine could go up to 30, 35, 40,000 RPM. So the cutting parameters that we would recommend, or mainly recommend, if you do not have that dynamic in the spindle would be these 42,000 RPM with a cutting speed at 50 meters per minute. We can see also that the cobalt chrome material is also, you can go much faster, reaching a cutting speed of 64,000 RPM. Once again, you don't have necessarily that dynamic on your machine, but we will be glad to give you the corresponding cutting parameters if you give us your limitation of your machine. We even can do some tests on we do have a Vilma Macodel machine in-house, so we can do the test to give you the best results or the recommended results. So you saw that the hole was made on an interpolating end mill. What I will show you here is a simulation of what our customers are mainly doing. So you see here a drill and chamfer first, and then a drill with two cutters. Then the roughing operation with the same cutter as before, so the 1450, doing the roughing step by step. Afterwards, you take the similar cutter with to make the finishing. So you see here really the interpolation going down to the bottom. Small information here. You saw at the beginning we did the hole and the chamfer on two different cutters. We do also have step drills with directly the cone made on the first step. This allows you to save one position on your machine, of course. So instead of having two cutters, you only have one. And you also obviously save time, so it's a double benefit for you. So don't hesitate asking us the list of drills, step drills for different hexalob dimensions. So we have the torques norm or dimension, and we definitely can make any kind of custom cutters if you wish. Talking about the results now, you can see here the result of the cutting that was done on the machine. So you see on the left hand side some of the torques print, and on the right a real big zoom on one machining or one print. You can see that the walls are really fine and really perfect. I mean, no vibration. The surface state is really astonishing, and also the chamfer is perfect. There is no burr at the connection, so you see you really have a perfect surface state. It's a T15 dimension, so it's let me calculate. You might have a 3 millimeters in diameter for the chamfer, for the upper level of the chamfer. So I talked a lot. Now it's your time to work. Maybe I can be sure that you see, here the different prints. So on one small diameter, you have a multiple print, and this is what you saw right before. So let me open the second questionnaire. And we would like to know in which kind of field you would use this kind of cutter. Talking about this, of course, it was meant to be used in the medical and dental, but I will talk about it later on. We also had some other astonishing application where this cutter was used. All right, so I talked about this cutter, the 4030 and 4050, machining the torque print or the hexalob print. But as said, so it's really important for you to know that that we can do any kind of modification, any kind of customization you would like to have. So do you want to have a bigger or smaller diameter? We can do that. Higher reach, it's also done. We also did sometimes a radius or a chamfer on the cutter for different question or different challenge from our customer. Even half radius or half diameter in the front. So we have different possibilities for you to get from us. Any kind of request, don't hesitate to challenge us for asking us this. All right, so it's your turn once again to work, and I would like to know in which kind of material this cutter would be useful. When you do answer this question or this questionnaire, I wanted to tell you that our customer use it in different material, and I already see a question that that was asked from you guys. Let me go back full screen. So yeah, I think I'm mostly done with the presentation. I hope you liked it, and I open up now the question the Q&R session, the question session. So I said I do have one here. So can we use this cutter in different materials? So once again, it was meant to be used, or it was developed for cobalt chrome, stainless, and titanium, but our customer used it also in jewelry, in gold, and we also have a really, I mean, curious, not curious, but strange application, which was used in a really, I cannot mention the type of material, but it was not from hers. So it was really astonishing to have this kind of machining. So yes, this cutter is working really well in various material. You can play with the I mean, cutting geometry, no, but with the coating. So the answer is yes. You can use this cutter in different other material. Okay, so what's the next question? If our machine is limited in rotation speed, would the cutter work? Oh yes, so that's what I said. We have a Vima Macodel machine back home, and we definitely can make some tests. So it's a balance between the speed and the cutting. I mean the speed, the rotation speed and the cutting speed, allowing the chip to be evacuated, allowing the cutter to work well. And yes, if you cannot work or make the spindle go that fast, you still can use that cutter. I mean, the diameter is so small that the fastest, the better. But if you cannot reach this kind of speed, we will be able to give you the correct parameters, the correct cutting parameters, yes, and give you that back as an answer. I hope I answered that question. What the third question? What is the life duration compared to a standard end mill? That's a that's a good one. It's really hard for us to give any kind of information about life duration. It's really difficult. What I would mention is due to its geometry, as I explained. So that was one of the challenge we had. We wanted to avoid any vibration, any yeah, cutting or breakage initiatives. And what we made was this radius, this 3 consecutive radius, to damp the vibration. So our customers really enjoyed using these cutters and gave us the feedback that it was really working outstandingly, and I mean, hired the life duration of their existing cutters if they had before, especially in stainless steel, titanium, and cobalt chrome. Okay, do we have another question? Okay, no further questions so far, so I will come back to you about the questionnaire. So let me give you some feedback about the problems you guys do have. Poor surface finish. So it was the most, or you all had this kind of problematic. So as you see, or as you could see on the picture, the surface finish using that cutter is really outstanding. So don't hesitate to give it a try, and you will be astonished by the results. The next, the second most impactant answer for this of the problem you have is the tool breakage. Okay, so here as well, as said lately, the different radius on the clearance really damp the vibration, allowing you to not have a higher level or a high level of tool breakage. Vibration coming next, which is also damped by the geometry. The bending, okay, the bending as well. The bending is an effect that you less see here, as I showed you also on the section of the cutter, as the section is bigger than a straight two angles. You have a really more rigid geometry with this cutter. So once again, give it a try, and you will be surprised at how strong it is. This is it. What the field? Well, this is not really astonishing, but we have about 80% of the application in medical and dental. More astonishing, given taking into account about the dimension of the cutter, is the automotive. So this cutter would be used in the automotive as well. Okay, with a 60% almost. Watch industry and aeronautic aerospace, but with a 33%, 11% on connector, and that's it. And at the end, what kind of material? Stainless steel. Okay, all of you, all of the people who answered would use this cutter in stainless steel, followed by titanium with 90%, cobalt chrome 50%, precious metals 25%, and brass 13%. Okay, good. So thank you very much for giving me this kind of feedback. I'll leave you here my contact information, so don't hesitate to contact me or my colleagues with the info@lbsa.ch. You definitely will be able to reach anybody that will be able to give you some more information about this cutter. In some days, you will also have the possibility to, or you will get an email with technical information that I presented you here on this webinar. You also will be able soon to see this video back on YouTube channel. And don't hesitate to push the limits with of your machining with our 1430 and 1450 cutters, with using this mini radius with a highest reach. Once again, don't hesitate to contact us for any custom requests. Thank you a lot. Thanks a lot for following me this afternoon or this morning, depending on where you are on the globe. I tell you to the next webinar. It will be next year in 2021. And I wish you all the best for this end of the year. Happy New Year, happy Merry Christmas. I'm sure that 2021 will be different than 2020. Take care, stay healthy, and don't hesitate to use our tool, and good machining.